Okay. Any questions throughout this? You can set this up a number of ways. If you decide you wanted to do it differently, that's fine. I don't think I'd solve in terms of y or x. You're going to get a funny looking fraction, and it's doable. It's doable. And 3 decimals. And yeah, this is small because your speed in your rowing and your speed of your current should hopefully be very small. Here were your tickets. Now, yes, you could do this with one variable. You could do your tickets, because you're a 429, you could say x and 429 minus x. I kind of like you to keep the 2 variables. We eventually do that anyway if you're going to solve for x. So the 452 minus x. Where did it go? Here. 452, if you did it that way. Kind of try to start with the 2. Pull the numbers right out of here. There are 2 prices of tickets. As soon as you see this, start your let statement. Get yourself 2 variables. I tend to stick to x and y. How many tickets of each? So you need to know the number of each. Remember to go back and see what it is you're looking for. If you want to do this combination, elimination, that's fine too. You can absolutely multiply this by -2 and do a combination, the elimination, the same combination. Elimination, this lends itself nice to substitution. Whichever way you solved it is fine. Make sure somewhere you have a let statement, and somewhere you bring it back to where your answer is. If you give me your let statement in terms of students at, student, non-students at, when you give me this, I will know they're students. So again, just make sure you come back to some answer. Don't leave that in there for me to find it. I'm having trouble finding and following everything else. Questions? These were the nice ones, right? These were the 2 variables. Kind of nice.
Yeah, number 3 was my favorite.
Here's another wind speed. Again, the wind speed, just remember that you're multiplying it by the time as well. They took different times each way, which makes sense. And probably that's the easiest way to do it. Whichever way you decided to solve it, as long as it's sound, I'm fine with it. And this makes more sense. Your plane speed is high. Your plane speed would not be 30 miles an hour, right? It makes sense that your plane speed is high. And even your tail speed, your wind speeds are a little higher. Your wind blows 30 miles an hour, 40 miles an hour. Make it make sense when you look at your answers. Questions? Okay, you guys a minute. I see a lot of you writing it down. Let me go over. Good? Here's an investment. Okay, now watch the investments. We talked about the investments yesterday. This is his money to invest. So that's the part that's going to be divided into 2 parts. We have two different interest rates. So remember, when you get the investment income, you have to take the amount that you invested times that interest. So don't forget to be able to do that. Here we did it here. The amount that you invested times that interest. This is your decimal. The amount times the interest. That's what he's collecting on his interest income. This is what he has to invest. He's going to split this up 2 ways. X to one way, Y to the other way. So that kind of lends itself nice to your first equation. and the interest income comes next. And remember, this is money, so 2 decimal places. Even though they could end up in fractions, your money, so you might as well just drop the 2 decimal places. Questions at all? You guys looking good? Okay. Everybody get this one? Did you catch the part that the whole mixture is 5 pounds? Okay. You have a 5-pound mixture. It's worth $2.80 per pound. The mixture contains peanuts that are $1.70 a pound and cashews that are $4.45 a pound. How many pounds of each are in the mixture? Okay, now whatever you put for the separate parts, the peanuts and the cashews, has to equal the total amount of the 5-pound mixture. It's a 5-pound mixture so you would go pay for this. I have to be careful the way I say this. Every time I say this, somebody has a little chuckle. You go pay for your nuts. So I have to be very, very careful how I say these because everybody laughs every year. So you multiply these out. This is what you're getting here. Your $14. This is what you're going to pay for this. And then you're just going to break it down. How does it break down into the separate components? But it's the 5-pound mixture that you have to catch. Everybody good with this one? Did you miss the 5-pound part? In the past, I've done this over the years so many times, and I recognize where kids mess up, and it's right here. They come back and say, I have nothing to equal this to. And go back and check it when you're done. Go back and check it that it actually works. Plug it back in. These are equations. Plug them back in and make sure they make sense. And they could come out with partial pounds as well. I know usually some kids either love the word problems or despise the word problems. There's no like happy medium with word problems.
Why do we need words in math, not numbers?
And some kids love word problems.
Oh.
Love them. I love word problems. This was
Word
before.
problems are not for me.
Okay, this one we did in class, right? Okay. And this is very similar to the one we did in class. They earn income from the investment. So this is your income earned from the investment. And you've got 3 variables. One at 5%, one at 6%, one at 10%. Okay, this is what you get annually from your interest. So interest has to mean X times that percent, Y times that percent, 10 times that percent. You have the Z times that percent. You have to add them up at the end to get this simple interest. No compounding, daily, monthly, just very simple interest, like we looked at yesterday. Now, once you set your let statements up, a good way to do this is put it over your words. If the amount invested at 5, this is your X, at 0.05, make sure it's 0.05, is 5 times the amount at 6. What is the amount at 6? Y. And the total amount invested at 5 and 6, that's the Y amount and the X amount, is equal to the amount invested at the 10%, is equal to the Z amount. Pull it right out of the words. Set up your let statements first, and then go back into your problem and plug them back in there. So you've got one equation right here. You've got another equation right here. And we can get our annual income right there.
Can you scroll down a little bit?
Sure. Everybody okay with setting this part up? Better? And again, these amounts didn't work out very nicely, but they're money, so give them 2 decimal places. Here's your 3 equations. This is your interest earned. This was your x was equal to 5y. This is your x plus y plus z. We looked at these. Now the hardest part is to figure out what variable do I use. So which one contains all the same? One that's the same. So I'm looking at the y. That's the same. I got an x and a y. I got an x, y, and z. So at least both of them contain a y. So if I could make everything in terms of y, I should be able to substitute in. The first one contains them all, so. Watch your decimals. Move it to the left 2 decimal places. And again, we talked about this yesterday for those that weren't here. We do this interest income, simple interest. The rates are high, yes, but if we did the rates like they are today, you'd hardly see any change in the equations. You wouldn't see any real big money difference. So we make them kind of obvious that you can kind of look at them and see the difference in them. This is the last one, right? No, one more? And then go back and check any of the equations and make sure they make sense. A good one to go back and check is the big one. Make sure all the interest income comes out to $1,000. And last, this is another one kind of like number 2. The only difference is we put 3 variables in here. The cost of a small, medium, and large soft drink. So right away you have 3 variables, x, y, and z. So pull out the cost of your large. This is your z. Is 1.75 times the cost of a small drink, x. There's an equation right there. Just pull them right out. Difference means what? Subtract between a medium and a small. Which one has to be more? Which is going to cost more, a medium or a small?
Medium.
A medium. So you're doing a medium minus a small. Y minus x is 0.20. There's another equation. And altogether, the total cost, there's your third equation. Pull them right out of the words. You want the cost of each one.
This was my second name.
This was your second paper. It's kind of like the other one. With the ticket,
Scroll down.
it just has one extra variable. But it's
pretty-
okay.
Pretty simple.
Yeah, they came out nice to be able to put them all back in. They came out nice in terms of substitution. Into 2 factors or whatever it takes, and generally we have 2 factors. That's what we're doing. We're going to put it as a sum of 2. We only really do 2. We factor the denominator. We write it as a sum. We multiply, because we'll make it an equation, everything by the common denominator. Then we're going to set the factors equal to 0 and substitute it in and rewrite our equation. It's not so bad. So, step 1, factor this denominator. X minus 3, okay? So we're going to rewrite this guy. And we're going to set it equal to the sum using A and B. Here's where the sum using A and B of both of those factors. Doesn't matter which one we put first. Then we're going to take, multiply, it's an equation, so we're going to find the least common denominator, which is your set of factors, right? And we're going to multiply everybody by x plus 2, x minus 3. So in the first case, this comes out, right? We get x plus 7. In the second case, I take out my x plus 2, and I have to multiply a by x minus 3. Then I take out x minus 3, b times x plus 2. Not so bad, right? It's always going to work out kind of nicely when you have a common denominator because you just factor them. And there's your common denominator. Now, we take both sets of factors. X plus 2 is a factor, and x minus 3 is a factor. So we take both of these, and we're going to set them to 0 one at a time. By setting them to 0, it means this. If I set this to 0, x minus 3, x would be equal to what? 3. So x minus 3 equals 0. Let's just go like this. So x would be equal to 3. If I put a 3 in here, doesn't this become 0? Doesn't this take this out? So then therefore, where's my only variable going to be? B, right? I'll solve for B, right? If I take this out, this becomes a 0. A times 0 is 0, right? I take this out, I'll solve for B. If I put x plus 2 equal to 0, then x is equal to negative 2. I'll take out the b and I'll solve for a. That's it. And then I'm just going to go plug them back in. So remember, this is an equation. So first time through, let's take out the x plus 3 guy, the x minus 3. We'll substitute in a 3. So substitute it in here. In here, this is going to come out. In here. So it's going to be 10. This comes out is equal to 5b divided by 5, and b is equal to 2. Good? Then we're going to come back to this statement again. This is a lot of rewriting. And now we want to solve for a. So we've got to take out the b factor. So we're going to plug in a negative 2 for x, which will eliminate b. So negative 2, every time you see x, this takes out this guy. So we get 5 is equal to negative 5a. And what's a equal to? Negative 1, right? A should be equal to negative 1. Divide by negative 5. I don't think I can fit this under here. Oh, no. Okay, so now we found A. Now, all we have to do is substitute it back into this piece right here, because we have already separated it. The one you want to do is put the negative. I'll substitute it in, and then we'll just reverse them. If I substitute this in, I get negative 1 over x plus 2 plus 2 over x minus 3. Now, generally what we like to do is put the negative second if it's the only one there. So instead, just make it 2 over x minus 3 minus 1 over x plus 2. So this fraction right here broke down into this decomposition. We decomposed it. We broke it down. You want to see that it works?
Wait, so do we set that equal?
Yeah, it's equal to this original guy. I just don't have any space here to put this. Equal to 7.
Check it.
If we check this, what's its common denominator? Okay, x minus 3, x plus 2. So we're going to do 2 times x plus 2 minus 1 times x minus 3. Collect your like terms. 2x plus 4 minus x plus 3 over this, which is x squared minus x minus 6. So this gives us x plus 7. Do we come out to the same thing?
Yeah.
Yeah. It's not wrong if you leave the negative one first, but it looks nicer if you put the minus second. Yeah, so that if you have two negatives, you don't get a choice. It just kind of makes it look a little bit better without the negative hanging out there. All right, so again, we're factoring your denominator, which makes it nice because when we multiply both sides, we got the factors already. And we're writing it as the sum of a plus b. Then we set each one of those factors equal to 0 so we can eliminate it from the equation. Once we find a and b, we just rewrite the equation. So this equation would finally look like this in the end. Not bad, right? Okay, ready for another one? We'll try another one. You panicked because you saw the word fraction, but it really wasn't that bad. Okay, again, start with factoring. You factor this, what does this factor into?
X minus 3, x plus 1.
Okay, x minus 3, x plus 1. Good. So we've got our two factors. We're going to set this equal to a over, doesn't matter which one, plus b over the other one. Okay. Now we're going to multiply everybody by the common denominator, which is your two factors. Everybody gets multiplied by x plus 1, x minus 3. So this guy, the denominator comes out. I have an x plus 1. X plus 1, I need an x minus 3. I have an x minus 3. I need an x plus 1. And then what?
Substitute on that.
Okay, so let's set them equal to 0. We have two factors. One at a time, we do these one at a time. So one time through, x is 3, and the other time through, x is negative 1. So this is the first time through. So we'll use x is 3. Is that okay? Don't forget this x. Okay, this gives us 15 minus 3 is 12. This comes out. We eliminated the a. So we just found b. Now you just got to rewrite it again. That's the only problem with this. It's kind of like you have to keep redoing this. But we're only doing two factors, so it's not so bad. Okay, then you're going to throw in the next one. And the next one is negative 1. And over my years of doing this also, if there's a mistake, it's usually right here. We usually forget to put it on this side. Because by the time you write it the second time, I've seen kids only write the one side of it. So make sure you write the whole equation out. Oops, negative 1. This time it eliminates the b. So negative 5 minus 3 is negative 8. So negative 4a, that eliminates. And a is equal to 2. So our final answer says, take this original problem. It breaks down. Since we don't have anybody that's negative, it doesn't matter which one, so we'll put the a first. It breaks down into those two fractions. And again, you can check it. That's your common denominator. Check it. Go up to get, your common terms together. And it should work out. Okay, why don't you try the next one? Try the next one and see what you come up with. Okay? So break these down, separate them. The only bad part, you gotta write it twice. You gotta solve for A by eliminating B, then solve for B by eliminating A, then bring A and B back into your statement, and, like in this case, just clean it up a little bit. You can't leave a complex fraction. Good? It's kind of a weird spot that we put this in here. It doesn't have to do with our